$636.
And that's the sale price I'm seeing. The list price is almost $800.
Right. For cable, I mean, that's the price of a pretty decent laptop, not an accessory. So for this deep dive, we are looking at the Kramer CLS-AOCDP-UF-230.
It's a bit of a mouthful. But what it is a 70-meter, so 230-foot active optical DisplayPort cable.
And that length is everything. We're not just connecting a monitor on a desk here.
No.
We are talking about sending a signal across, the entire length of a hockey rink? So the mission today is to figure out how you push an 8K video signal that far without it just turning into mush.
Well, it really just comes down to physics. A normal copper cable, the kind you have in your drawer, it has resistance.
Attenuation?
Exactly, attenuation. The signal just degrades. And with something as data heavy as 8K, if you try to send that down 70 meters of copper,
you get nothing.
You get absolutely nothing. The signal will be gone before it even got there. Which
I assume brings us to the AOC in the name, Active Optical Cable. This is a hybrid, right?
It is. It's a really smart design. Under the jacket, you've got 4 strands of multi-mode fiber optic for the video.
For the heavy lifting.
Right. And then you have 8 standard copper wires running alongside them for things like power and control signals.
So the cable itself is actually a media converter.
That's the perfect way to think about it. Inside those DisplayPort connectors, which look totally normal, there are tiny 850 nanometer lasers.
Wow.
Yeah. It takes the electrical signal from your computer, turns it into pulses of light, shoots it down the glass.
And then turns it back into electricity at the other end for the display.
Exactly. And because it's light, there's basically 0 signal loss over that 230 feet.
Okay, but usually when I hear active cable, I think external power, you always get those clunky USB plugs or wall warts hanging off them.
That's the standard annoyance, for sure. But Kramer engineered around it here. This thing is so efficient, it draws less than half a watt of power.
Less than 0.5 watts. So it can pull power directly from the DisplayPort source itself.
It just sips it. So it's truly plug and play, no external power supply needed.
That is a massive deal for an installer. I mean, if you're pulling this through a ceiling conduit, the last thing you want is to find an outlet up there.
Oh, absolutely. And speaking of the pipe itself, we should talk bandwidth. This supports HBR3.
High bitrate 3. So we're talking 32.4 gigabits per second.
That's the number. That's what gets you full 8K resolution at 60 hertz, totally uncompressed, plus, 8 channels of high-def audio.
It's just a fire hose of data. But physically, it doesn't look like one. The specs say the diameter is only 4.8 millimeters.
It's super thin. Thinner than a lot of high-quality copper cables. And I know people hear fiber and glass, and they worry it's fragile.
Right, that it'll just snap.
But this has a bend radius of 48 millimeters. You can actually pull it through conduit without destroying it.
And for pulling it through, say, an office building or a school, there's one acronym here that's critical. LSHF.
Low smoke, halogen free, which is vital for fire codes. A normal PVC cable, if it burns, releases all sorts of toxic halogen gas. This won't. It's fully compliant with RHHS-CE, all the major safety standards.
So when you put it all together, you've got this hybrid fiber copper system with gold-plated connectors, self-powering lasers inside, all to shoot uncompressed 8K video across a building.
Yeah, that $600 price tag starts to sound less like a crazy markup and more like, well, a piece of precision engineering.
It's solving a physics problem that copper simply can't.
It really is.
But, here's a thought to leave everyone with. We need fiber optics and miniaturized lasers just to move today's 8K signal 70 meters.
We're pushing the limits of the tech we have right now.
So if this is what 8K requires, what does the infrastructure inside our walls need to look like when 16K becomes the standard? Are our homes ready for that?
And it is the billion-dollar question, isn't it?
Thanks for listening to this deep dive.